In this lecture, we're going to discuss theory. So far, we got the enemy to chase the player. That's great, but the current implementation is not scalable. We're going to run into a common pitfall that most beginners encounter. To understand why, let's look at pseudocode. Pseudocode is another way of saying fake code. If you were to copy and paste pseudocode into your game, it wouldn't work. The purpose of pseudocode is to help us visualize and discuss potential code solutions. If you ever work with a company, you and your teammates may use pseudocode to discuss ideas. Take the following example. This snippet was borrowed from the enemy controller file with a slight modification. It's checking if the player is within distance. If they are, the enemy will be chased. Simple so far, right? But what happens when the enemy is within attacking range? The enemy would stop chasing and begin attacking. Once again, we can use a conditional statement to perform this check. What if the player runs away while the enemy is attacking? It's possible that the player may not be within attack range but is within chasing range. If that's the case, chasing should resume. Eventually, the player may outrun the enemy. The enemy should return to guarding their original position or continue their patrol. What if the enemy is defeated? We should account for this event too. Do you see the problem? We have an endless chain of conditional statements. Conditional statements are not bad. There isn't a rule for how many you can have. However, it can be difficult to manage when you have a long list of conditional statements. What if you need to add new actions? It can be difficult to scale this solution. So, what can we do? We can use a design pattern. In the programming world, developers are constantly facing problems with scalability. Design patterns were introduced to help developers scale their code. What is a design pattern? A design pattern is a solution to common problems. It's a specific way to write code for scalability. Frequently, developers may feel intimidated by design patterns. They can be difficult to learn. However, they're incredibly beneficial to learn. As stated before, they were created to address common problems. You're likely going to face the same problem from game to game. Being able to resolve those issues will make you a better developer. In our case, there happens to be a design pattern for addressing the issue we're encountering. It's called the state pattern. Before getting into the state pattern, we should understand the concept of state. State simply refers to the current action performed by an object. If an enemy is attacking, they're in the attack state. If they're guarding, they're in a guard state. If they've been defeated, they're in a defeated state. So on and so forth. This leads us to the state pattern. The state pattern is a programming concept for switching between different states. Best of all, it can scale with your games. You can add as many states as you'd like. Switching between them will become easier. Our enemies can be patrolling, guarding, chasing, or attacking. Each of these actions can be considered states. Using the state pattern will make it easier to switch between each state. Switching to another state is known as a transition. Now that we've discussed the theory, let's try implementing the state pattern. I'll see you in the next lecture.